The rationale for statistical inference. So, to understand this here, let's take the example of the political context. We understand that politics has an impact on our lives, on our wallet, on our health, and what we can do and what we cannot do. So, it makes sense we are concerned about the politics in our country, in our context. And if we are concerned about it, there are many questions about the politics we may want to answer. So, for example, how much money is each political candidate is raising, and why would we be concerned about that? Well, for many different reasons. You may be just curious about how much money they're each raising, but you also may want to try to predict who is going to win so you can make decisions about your life that will be related to who wins in the political contest. And there are different ways to think about statistical inference here. So there's we kind of mentioned before. So there's just the descriptive way. So it's just statistical thinking or statistical calculation. Let's say descriptive uh, quantitative calculations, quantitative, descriptive, and quantitative inference. And then there's also more of the deeper or causal inference that we're actually concerned about. So when we are, for example, getting the fundraising amounts for each candidate, counting that, and counting how much of that fundraising was spent, and then maybe seeing the difference of how much money they got and how much money they spent, and then maybe seeing the ratio between the two. So we see that 278 here and then 275. So what's the difference between these two? Well, we can say it's $3 million, but it's also you can divide it to seven. You can do a subtractive difference, or you can do a division difference, and so on. So that's more on the descriptive quantitative side, right? But we can also look at more on the causal side too, and that's where the inference comes in. So, for example, in the inference is why is Biden raising more money, or is Biden raising more money over time, or is it just in one day? And so on. So we can take maybe a long term look as well regarding how Biden raised money compared to Trump instead of just maybe just 1 month or in one cycle, but also maybe Democrats and Republicans over time. So, maybe you may ask, why is Biden raising more money? Well, if we look over time, you can see maybe that Democrats raise more money than Republicans. Now, I don't know if that's true, but if we take a look over time, we can kind of help us answer this kind of causal, long term, and deeper types of questions. And this is where statistical inference comes in. Following along with this notion of cause, so with statistical inference, we can address things such as, does pesticide impact bee sleep? So, impact is the causal term here. And we can look, and why would we need statistical inference? Well, once again, first, if we're going to look into quantitative measures such as sleep hours and amount of pesticide that the bees have consumed, then we already engage in some kind of statistical thinking and quantitative thinking. And so that's the first part. We're already doing it because we're concerned about bees and we want to know what's going on with bees and bees sleep. And you may identify some quantitative data and you see where bees are sleeping. You can kind of tell just by looking at some data. Here's organized increasing by sleep. So you see that the more they sleep, it seems the less pesticide amount they have ingested or they have been exposed to. Now, this is just descriptive, and it's not deeper inferential or conclusive determination that they are related, because once again, this could be some correlation and not causation. Also, so that's one of the issues, right? Correlation, not causation. Correlation versus causation. The other issue is, well, the sample. And that's one of the major things we keep talking about here. Is this just by chance we got a sample of bees where we see this pattern? But if we were to expand to the whole population, would we continue to see this pattern? And that's what statistical inference does. It helps us expand from the sample to the whole population of bees. So the rationale for statistical inference similar to the rationale for research, but establishing more of this consideration of fact of samples and chance. So because we often deal with samples and only a part of the population, we want to extrapolate and make conclusions about the whole population from a sample. Of course, for example, when we do studies in vaccines and other medical studies, we cannot give medicine on a study to everybody because, first of all, we don't even know if the medicine works. So why would we give the medicine to everybody? And also, it's just unfeasible. There's too many people in the world. There's billions of people, and maybe we can only research a few thousand. So consider the fact that we only have samples. We only have samples, and some results can be by chance. So statistical inference leads us to uh, what we call, maybe we can call population knowledge or population information. And also, once again, of course, identify these causal relationships. We can see, yes, there's so much consistent relationship between pesticide and bees that we can say that with some degree of confidence that probably there's a causal relationship. And once again, of course, related to the rationale for research in general to improve prediction and reliability of our information. So I'll leave you with this for now, and we'll continue next time.